Hello students, in the previous video we have seen what will be the nth term of an AP in terms of its sum, and in this video we are going to discuss a few properties of an AP. So if suppose A1, A2, A3 so on up to infinite terms is an AP whose common difference is D, then for some constant number k belonging to real numbers A1 plus or minus k, A2 plus or minus k, A3 plus or minus k, this series will also be an AP with the same common difference D. This we can prove this by taking a simple arithmetic progression a comma a plus d comma a plus 2d comma so on. So in this the first term is a and the common difference is d. So now we can either add or subtract k to all these terms. Then this will become a plus or minus k comma a plus d plus or minus k comma a plus 2d plus or minus k. Then consider a plus, let's take a plus or minus k is equal to b. Now replace the term a plus or minus k with b. When we do this in the series, a plus or minus k is b, comma. Here the second term is a plus d plus or minus k. So this can be written as b plus d. And the third term will be written as b plus 2d, comma so on. So here also you can see that this is an arithmetic progression with common difference equal to d. But the first term is b instead of a. First term equal to b, which is equal to a plus or minus k. Now if we consider this series that we are multiplying every term with k, so the series will become k into a1, k into a2, k into a3, so on up to infinite term. Now this will also be an AP, but the common difference now will be k into d. We can prove this by taking a simple example. So consider the same arithmetic progression with the first term as a and the common difference d. So now the series will be a comma a plus d comma a plus 2d comma so on. Now I'm going to multiply every term with k. So when I multiply every term with k, this will become k times a comma k times a plus d comma k times a plus 2d so on. Now we can see that this is k times a comma k times a plus k times d comma k times a plus 2 into k times d so on. Now here also we can substitute. So let's take k times a equal to b. Then we'll have b comma b plus kd comma b plus 2 into kd comma so on. So here also you can see that this is an arithmetic progression. This is an AP with common difference equal to kd because we are adding k into d to every term, right? With common difference equal to kd, and the first term equal to b, which is equal to k times a. So here we have seen that the common difference is becoming k times d. Here k can be any real number. So if suppose I am taking k equal to 1 by r, that means the new series, the new arithmetic progression series will become a1 by r, comma a2 by r, comma a3 by r. So here we have taken that k can take here. So here k can take any real value. So suppose it was a fraction. That means k can be equal to 1 by r. Now where r will be a real number but not equal to 0 because 1 by 0 is not defined. So now the series will become a1 by r, comma a2 by r, comma a3 by r, so on. This will also be an AP with common difference equal to k into d. Since we took k equal to 1 by r, so it will become d by r. This is also one of the properties of arithmetic progression There are some more properties of arithmetic progression which need to be discussed, and we'll be discussing them in the next video. Hope you understood well. Thank you.